Welcome to my presentation. In this presentation, we shall look at some examples related to factoring monomials. Let us take an example, and in this example, we want to find the greatest common monomial factor, and the expression given to us is 15 minus 15a to the power of 2 plus 45a to the power of 3. So let us use these different steps to explain this procedure. Between 15, 15 and 45, 15 is common. So, 15 is common. So we want to also see if A is common in all of the terms. In the first term, we have just the constant number 15 and we do not have any A term or the variable term associated with it. The second term has a to the power of 2, the third term has a to the power of 3. Since we do not have a's as constant throughout, as a variable term throughout the expression, we cannot pick it as a common. So therefore, we want to look at the coefficient terms. When we look at the coefficient terms 15, 15 and 45, 15 is common. 45 is a multiples of 15. So if I were to pull out 15, we can write this as 15 times 1 is 15 minus 15 times 1 is 15 times a squared is a squared. 1a squared or just a squared means the same thing. Then plus 15 times 3 is 45, and then I can write a cubed next to that. So therefore, we have factored the given trinomial in this manner, and the greatest common monomial factor in here is 15. This is the greatest common monomial factor, and that is the way we want to be able to express this these types of problems. Okay, so let us take another example, and in this example let us see if we can find the greatest common monomial factor if we have two variable terms involved. So in this example, let us say we have 3x y to the power of 2 minus 15x squared y plus 12xy. Let us say we have an expression like this, and we want to find the greatest common monomial factor here. So to do that, let us break it down into these different steps. Here again, I want to write this as follows. If I look across the equation, I have 3, 15, 12. Those are the coefficient terms, and I have x, y squared as the variable terms, x squared y as the variable term, and xy as the variable term. So just for our understanding sake, if I have x squared, I can write that as x times x. If I have y squared, I can write that as y times y, isn't it? If I have 15, I can write that as 5 times 3 as 15. If I have 12, I can write that as 4 times 3. So therefore, I can write this one as 3x y times y minus 5 times 3 is 15 times x times y plus 4 times 3 is 12 times x times y. That is the way we want to write it out. And now we want to look for if there is anything common here. 3xy is common in all these terms. This is one term, this is another term, this is another term. Then we have 3xy is common in the second term as well, and then 3xy is also common in the third term. So therefore, if we were to put all these things together, we can write it as step number 2 as follows. If I were to take out 3xy as common, what is left in the first expression? Y. What is left in the second expression? 5. And what is left in the third expression? What is left in the first expression is y. What is left in the second expression is is 5, there is an x to the power of 2. I think I missed something here. 5 times 3 is 15, and we have x to the power of 2 here, and then we have and then y. 4 times 3 is 12 times x times y, and therefore here we're going to, since we pulled out 3xy common, so we are left with 5x in here. And in the third expression, when we were to pull out 3xy, we have a positive 4 left. Therefore 3xy is the greatest common monomial factor for this given expression. And this is the way we want to be able to identify or isolate the greatest common factor, which is a monomial in all of these examples we have seen, because 3xy is one term. Therefore these are monomials. There's one term which is common in the given expression, and therefore when we pull it out, we are factoring it out, and therefore that is the way we want to express our answer. In my next presentation, we shall look at some more examples related to examples dealing with factoring monomials.